Jyoti Mayekar, and this is 15th lecture on atomic and molecular physics. In the last lecture, we studied about the Pauli's exclusion principle. In this particular lecture, we are going to talk about symmetric and antisymmetric wave function. So, suppose we consider a system of two identical particles, one particle 1 and particle 2, and let these two particles, they are in two different states. Suppose particle 1, it is in state A, and particle 2, it is in state B, and we will use a wave function psi of 1 comma 2 to describe this system. Now let us consider another system. Suppose now the particle 1 is in state B and particle 2, it is in state A. Then we can describe that system by a wave function psi 2 1. So we have a two wave functions psi 1 2, psi 2 1. Psi 1 2 means I have two particles 1 and 2. One particle 1 is in state A, particles 2 is in state B. Psi 2 1 means I have two particle system where particle 1 is in state B, particle 2 it is in state A. Now, since the particles are identical, the probability density on exchange of particles should remain same, and we know that probability it is nothing but absolute value of absolute value of square of wave function psi. So I can write that psi absolute value of psi of 1 comma 2 square, it is equals to absolute value of psi of 2 comma 1 square, and suppose this is equation 1. Now hence the wave function psi 2 comma 1 representing exchange particles I can write in two ways, by taking square root of both the sides. अगर मैं square root लेती हूँ दोनों side का, I will get two equations. Psi of 2 comma 1 is equals to psi of 1 comma 2, or psi of 2 comma 1 it is equals to minus psi of 1 comma 2, because square of negative number is also positive, right? Now equation 2 and equation 3, they represent two kinds of wave functions that possess symmetry property. So equation 2 जो है psi of 2 comma 1 is equals to psi of 1 comma 2, that means a wave function is said to be symmetric if an exchange of pair of particle leaves the wave function unchanged. Here the wave function is remaining same even if I exchange particle. Now let us talk about antisymmetric wave function. Look at this equation. Psi of 1 comma 2 is equals to minus psi of 2 comma 1. That means when a wave function changes its sign on exchange of particles, then that is called as antisymmetric wave function. So it should be understood here that Hamiltonian does not change on exchange of identical particles, and as the Hamiltonian it is not changing, therefore both wave functions, symmetric and antisymmetric wave functions, they will satisfy Schrodinger equation. And also if we take a linear combination of symmetric and antisymmetric wave function, that will also satisfy Schrodinger equation. Now, whenever we describe a wave function for a system of identical particle, either that wave function has to be symmetric or it has to be antisymmetric. There is no other way. Either it is symmetric or antisymmetric. Now, let us apply Pauli's exclusion principle. So, what is the application of Pauli's exclusion principle? Now, here we are trying to prove that system of electrons are described by antisymmetric wave function. And if we have to prove this, then we need Pauli's exclusion principle. So, in hydrogen atom, there is only one electron, and its wave function is given by psi is equals to, it is a function of r, theta and phi. And when we derive the Schrodinger equation for hydrogen atom, that time we considered that psi, wave function psi, it can be written as a product of three independent functions, capital R, capital theta and capital phi, where capital R it is function of R only, variable R only, capital theta it is function of variable theta only, and phi function it is function of variable phi only. So in the same fashion, it is possible to show that for a system of n particles acted upon by the same force field, the complete wave function, suppose we have a complete wave, we have n particles, then we will write down the wave function for that as psi of 1 comma 2 comma 3 comma 4 comma 5 comma up to n. So using similar analogy, we can write psi of 1 comma 2 comma 3 up to n is equals to psi of 1, psi of 2 एंड सो ऑन अप टू psi of 3. तो हम लोगों ने क्या लिया, जैसे कि वेव फंक्शन साई जो हम लोगों ने हाइड्रोजन एटम में डिफाइन किया था, सो वी यूज्ड वेरिएबल सेपरेबल मेथड वेयर वी कंसिडर्ड कि साई जो है वो 3 फंक्शंस का प्रोडक्ट है, आर थीटा फाई, एंड दिस आर थीटा फाई आर इंडिपेंडेंट ऑफ ईच अदर. सो वी विल यूज सच सेम एनालॉजी. और यहाँ पे हम लोग क्या डिफाइन कर रहे हैं, वेव फंक्शन साई एन पार्टिकल्स का हम लोग कैसे डिफाइन कर सकते हैं, इट इज द प्रोडक्ट ऑफ इंडिविजुअल वेव फंक्शन फॉर ईच पार्टिकल, जैसे कि साई ऑफ 1, साई ऑफ 2 एंड सो ऑन अप टू साई ऑफ 3, साई ऑफ n. नाउ कंसिडर 2 इलेक्ट्रॉन सिस्टम. हम लोग 2 इलेक्ट्रॉन सिस्टम कंसिडर करते हैं एंड सपोज द 2 इलेक्ट्रॉन्स आर electron 1 and electron 2, and let A and B be the 2 particle states in the system. If particle 1 is in state A and particle 2 is in state B, then I can write wave function psi as psi A1, psi B2. This means my particle 1 is in state A, particle 2 is in state B. Now these are the individual wave functions specifying particle 1 in state A and another in state B. Now if particle 2 is in state A and particle 1 is in state B, then I can write this function as psi A2, psi B1. That means my particle 2 is in state A, particle 1 is in state B. So both type 1 and type 2 are the solutions of Schrodinger equation, and a linear combination of them will also be a solution of Schrodinger equation. So what we are doing here is we are constructing the most general solution depending upon the properties assigned to them. So these are the properties which are assigned to them. So let us consider the following properties. First property which was assigned is particles are identical. So total wave function will be symmetric wave function. It will be C1 some constant multiplied by the addition. So psi A1 plus psi A1 psi B2 plus psi A2 psi B1. And antisymmetric wave function will be same but with minus sign in between. Here the C1 and C2 are normalization constant, and if you solve them you will get the value of C1 and C2 as 1 by root 2. Now second which we are going to use is particles have spin half. These are the half integral spin particles. So if the particles are half integral spin particles, there is a further restriction which is imposed upon them. So that restriction is half integral spin particles, they obey Pauli's exclusion principle. Zero or integral spin particles, they do not obey. So second obligation which is there on the particle is they have to obey Pauli's exclusion principle. And according to Pauli's exclusion principle, no two particles can be in the same quantum state. So there are 4 quantum states, n, l, ml, ms. So Pauli's exclusion principle क्या कहता है कि चारों quantum numbers for a one particle, it cannot be same. So no two particles can have all the 4 quantum numbers same, or in other words we can say no two particles can be in the same quantum state. So our wave function in the above discussion will vanish for A is equals to B. If I consider A equals to B, then it will not obey Pauli's exclusion principle. So we see that psi symmetric is not equals to 0 if we put A equals to B, and psi antisymmetric it is equals to 0 for A is equals to B. Hence psi is not an acceptable wave function for our system of electrons. So what we conclude here is a system of electrons or any half integral spin particles described by antisymmetric wave function, that is wave function that reverses sign upon exchange of any pair of particles, because both the particles they cannot take the same state, same quantum state. And the zero and integral spin particles on the other hand do not obey Pauli's exclusion principle, and therefore they are described by symmetric wave function. Okay, so just remember that zero or spin integral spin particles, they do not obey Pauli's exclusion principle, and that is why the system of bosons it is described by symmetric wave function. On the other hand, as we know that fermions, they have half integral spin, they obey Pauli's exclusion principle. So there is one more restriction on them, that no two particles can be in the same it can have a same quantum state. That means they are obeying Pauli's exclusion principle, and that is how if we want to describe a system of electrons, then we will have to use anti-symmetric wave function. So that's all about this. Thank you so much.